Okay, this is 7.2. I forgot to change this. It's not, we deleted a lesson there. So it's 7.2 and 7.3. So now, again, our first lesson was just practicing the math we're going to be doing with the proportions, having to cross multiply and do all of that. Now we're going to be officially transitioning to the geometry side, which is applying it to pictures. We're going to do that a little bit at the end of the first lesson, but now we're going to be seeing pictures from here on out, yeah, and how they are similar, how they're proportional to each other. So again, we talked about that similar means, and let's write this down real quickly here. Similar means same shape, just in general, but different sizes. Now, what we're going to do is we are going to be proving that these two shapes that we're given, or however many shapes, do actually have the same shape. Because even if they might look like it, you're like, yeah, the shapes of these look the same. We have to prove it, right? We can't just look at it and be like, yeah, it's the case. Now, here are the rules, and I want you to underline these for proving this is true. What ends up happening is the corresponding angles are actually the same. So you notice here B is the same as F, C is the same as G, H is the same as D, so forth and so on. Those actually are identical, and that's how we get the same shape, is the angles the same. The angles aren't changing. What's different, again, is that the lengths are proportional, and we're going to show that. Again, proportional means that every single side length is just being multiplied by a certain number, the same number, to get from one shape to the next. So one shape might be twice as big, every single side length is twice as big. It might be a fourth as big, every single side length is a fourth as big as the other. But again, the angles are the same, sides are proportional. So we're going to be talking about that. The other thing we'll be talking about here is a scale factor, but we'll talk about this a bit more in class. What I do want you to write down is, it says the ratio of the lengths of two corresponding sides, blah, blah, blah. Ratio, again, do not get freaked out by that word. It's a fancy math word that just means fraction. So what I want you to write down for this is my scale factor is going to be my new shape compared to the old shape. It's a fraction, again. My scale factor is a fraction that compares my new to my old. So write that down for right now, but we'll come back to that in class. So let's go ahead. We're only going to do the first two problems here, talking about a statement of proportionality. So again, if two shapes are proportional, that means how their sides compare to each other is consistent for all pairings. So what they do is they tell us that these two shapes are similar. Now again, you guys should know by now that the order of the letters is no accident. It's very intentional, right? So JK being the first two letters and ST being the first two letters is no accident. We can actually see kind of based on this picture. Can't always tell based on the picture, but those correspond to each other. So what we're going to do is we're going to write those in a ratio, in a fraction. JK compared to ST is just going to be one fraction. Now, since they are saying that these shapes are similar, what's going to happen is this is going to equal my fraction for all of my other sides compared to each other. So coming back up here, again, I'm doing this based off the similarities, these letters, not just the picture. My next side, I had JK, then I have KL. See how, again, JK, then KL. I had ST, now I'm looking at TU. And again, KL and TU, we can tell based on the picture that they correspond to each other. So we're going to put those in a fraction as well. Now I have to be very careful that because I put JK on top, yeah, all of these side lengths are going to be the top of my fraction. All of these side lengths are going to be the bottom of my fraction. I can't just flip these and have it mean the same thing, right? Again, we talked about on Friday, 50 over 100 is not the same as 100 over 50, so we can't just flip. So I'm going to go ahead and write another fraction. I have KL is going to go on top, and that's going to correspond to TU. Now, again, what this means is, for example, in order for these side lengths to be proportional, maybe this is 4 and this is 2. We can say that going from 4 to 2 is half, right? If this is 2 here, then this would need to be 1. That's the same proportionality. 4 to 2 is half, 2 to 1 is half. So this will actually be true for all of our sides. So what I want you to do from here is I want you to keep writing your fractions. I'll go ahead and I'll write one more. And again, we can go ahead and look at our picture as well. My next one I have is LM to UV, and we can see that here. LM to UV. LM has to go on top, UV has to go on bottom. Go ahead and write the last two fractions. There's two more sides. What would they be? Okay, well, our last two fractions are going to be MN over VW. If you guys change the letters, you know that's fine. And then I'm going to have NJ to WS. Again, if you flip-flop letters, this is fine. So again, what this tells us is all of our corresponding pairs of sides have the same proportionality. We're going to work with this more in class, but let's try it one more time on this next slide. So again, it tells us right here, A, B, C, D to P, Q, R, S. Be very careful with this. Again, A, B is the first two letters, P, Q is the first two letters. That's how we know what goes together. Let's go ahead and make this first guy the top of our fractions. Let's make this guy the bottom. It doesn't actually matter which way you write it. You could switch those. That's fine, as long as you are consistent. Go ahead. You are going to have four fractions. 1, 2, 3, and 4. We'll write that one there. Comparing one side from one shape to the corresponding side of the next shape. What would those be? Okay, well, we have A, B. I'm going to put that on top again. 2, P, Q. And that is what it says up here. A, B, and P, Q should go together. Then I have B, C, and I want to double check. Here's B, C, my middle two letters. That should go with Q, R. And good, it does, according to the picture. So B, C on top, Q, R on bottom. Always want to check that similarity statement because we can't just base off the pictures. And then I have C, D, and R, S. So C, D, and R, S, that is correct as well. C, D, R, S. And then we got the last one, D, A, and S, P. Yep, D, A, and S, P are my final letters there. So D, A on top, S, P on bottom. Once again, doesn't matter if you flip-flop the letters. You could call this A, D, and PS. It's just that all of my sides from this shape had to go on top. All of my sides had to go on the bottom. So once more, in class, we'll continue to work with this so we have a really full understanding of what this really means. Obviously, there's no numbers yet, but we'll show in class how we can use this to answer questions about if these figures are similar